Hello everyone and welcome back to the C++ 3D game tutorial series. In this 25th video tutorial, we will talk about the making of a 3D scene. In particular, we will see how we can load and merge multiple objects from an OBJ file, how we can apply materials over the surface of different meshes, and in the end, we will see how to render all these meshes on the screen, making in this way a full 3D scene. As always, we will face three main parts: requirements, design, and implementation of all the necessary things to make a 3D scene. So let's start with the requirements. We need a C++ IDE, Visual Studio is recommended, the target platform is Windows. We also need DirectX 11 SDK, and last but not least, a bit of knowledge of C++ programming language is recommended. Now we can start the design part. Today our goal is to make a 3D scene. In particular, we want to make a scene with a sand terrain, an old house, and other objects like barrels and wooden boards. In this moment, we have two main ways to make a scene. One is to add 3D objects one by one through code. But there is another way that consists to make a 3D scene through a 3D authoring tool like Blender, 3ds Max, Maya, and so on. In this video, we will not focus on how to create a 3D scene in Blender, but how to load and render a 3D scene exported from Blender in an OBJ file through our 3D engine. As we have already seen in the 18th video tutorial, we parse and load OBJ files through the TINYOBJ library. Let's make a review on how an OBJ file is handled through the TINYOBJ library. An OBJ file is composed by 0 or more shapes, or meshes. For each shape, we have an attribute structure and a list of faces. Attributes is a structure composed by lists of vertices, normals, and texture coordinates. A face, instead, is the base element or primitive used to compose a mesh. A face can be a point, a line, or a triangle. For example, this bunny is composed by triangle faces. Very well. So far we have supported OBJ files with no more than one shape. But now let's see how to extend the support to an unlimited number of shapes. Let's take our vertex and index buffer. In this moment, we store the vertices and indices of a single shape or mesh. Now, how can we add another mesh? We can simply add contiguously the vertices of the second mesh inside the same vertex buffer. The same thing is applied for the indices. At this point, we can use this approach for any number of meshes. This approach organizes the data inside vertex and index buffers by objects. So far, so good. At this point, we will have multiple objects rendered at once. But there is a problem with this approach though. Now we can render more objects like house, barrels, wooden boards, and so on. But they are rendered with the same identical material, and so with the same shaders and textures. That's not good. We have to find a way to render each object differently. This can be done by using materials that we have seen in the previous tutorial. How can we do this? Let's take our house model. When an object like the house is modeled inside a 3D authoring tool like Blender, one or more materials with specific parameters and set of textures are assigned to its surface in such a way to be rendered in the way the artist wants. In this case, the house mesh has three materials over its surface: the brick, the wood, and the windows. The way in which the material is assigned to the surface of a 3D mesh is done by assigning the ID of that material to each face, and so each triangle. Usually this ID is numeric. At the end, all this information are exported in the OBJ and MTL files. So good, but how can we retrieve and use this information? TINYOBJ provides directly for each face the material ID assigned to it. Very well. At this point, we have to find a way to integrate the materials concretely. As we have seen previously, vertices and indices of the various objects are organized by objects. So, in order to consider the materials, we have to reorganize them not more by objects, but by material IDs. So, for each material, we have to check the faces of each shape. If the material ID of a particular face doesn't correspond to the ID of the material we are currently considering, we discard it and continue with the next one. Otherwise, we have to simply push the various vertices and indices inside our vectors. So now, for example, from index 0 to index 999, we will have all the faces with the wood material, so the door, the roof, and the boards. From index 1000 to index 1999, we will have instead all the faces with the barrel material, and so on in this way. This will allow us at the end to render multiple objects with multiple materials. Well, but how we can do this concretely? So far we have used this approach inside the draw mesh method of app window, where we set a single material and we draw only one set of faces or triangles. But now we have to review the approach a little bit. Let's take our reorganized vertex and index buffers. If we want to draw the set of faces or triangles with the barrel material upon them, we should find a way to tell to our graphics engine to draw the faces referenced by the set of indices that goes from index 1000 to index 1999. But how can we tell to the graphics API to use only a portion of the index buffer? Through the draw indexed triangle list method. Indeed, it accepts three parameters. One is the size of the portion of the index buffer we want to consider, and the last one is the start index of that particular portion. So, to draw the faces with barrel material, we should set the start index to 1000 and the size always to 1000. Very well, but unfortunately there is another problem yet. We haven't saved the start index and the size of the index buffer portion for the various materials. To solve this issue, we can create inside the mesh header file a data structure called material slot, where we have to add three attributes: the start index of the portion, the size of the portion, and then the material ID. Once we have done this, we have to create a list of material slots, whose size equals the number of materials loaded from the MTL file. At this point, for each material, we have to get the correspondent material slot, and here we have to set the start index, the material ID, and once all the shapes have been processed for a particular material, we have to set the size of the portion for the correspondent material slot. And that's all. Now, in the draw mesh method, for each material applied on the surface of the mesh, we retrieve the correspondent material slot through a suitable function, like getMaterialSlot. And finally, we draw the set of the faces with that material upon them by passing the start index and the size of the index buffer portion to the draw function. Very well, we have all the necessary information to start the implementation. As first thing, let's go to Mesh C++ file. Here, in order to retrieve the materials data, we have to pass the directory in which the NTL file is placed. We use the same path in which the obj file is placed. With this line of code, we simply get the path in which the obj file is placed, without its file name. At this point, since we want to support more shapes, let's remove this check. As we have seen in the introduction, the size of the vertex and index lists should be the sum of the size of all the indices lists of all the shapes. Very well. At this point, we have to loop over all the materials retrieved from the NTL and OBJ files. Now, we have to create the material slot data structure in order to say the various data we have already seen in the introduction. So let's go to mesh header file and let's do it. The next thing to do is to add the vector or material slots. After the resize of vertex and index lists, let's do the same thing for material slots. The size should be equivalent to the number of materials retrieved from an TL file. At this point, let's set for each material the start index of the correspondent material slot. For the moment, we can set such index by adding a new numeric counter called index global offset. Now, let's set the material ID, that is simply the numeric material index. Here, as we have already seen in the introduction, we have to consider only the phases with the material we are currently considering. Let's implement this check. At this point, since now we are considering multiple shapes, we have to push into our index lists an index global offset or counter, and not a simply index offset that consider only one shape, as we have done previously. Good. Obviously, this global counter must be incremented exactly in the same way of the previous counter. The difference between the two counters is that the scope of index offset ends with the processing of a single shape. At the end of the processing of a specific material, let's set the number of indices to the correspondent material slot. So far so good. The next thing to do is to retrieve the material slots data. Let's add two methods in the mesh class, getMaterialSlot and getTheNumber At this point, we can go to App Window class. As first thing, let's change a bit the draw mesh function. Now, we have to pass a list of materials and remember to pass the vector by reference. As we have already seen, to draw a mesh with multiple materials, we have to do in this way. For each material, and so for each material slot, we have to bind the material we are currently considering to the graphics pipeline. Here, since our mesh has only one vertex and one index buffer, we can set them only once, outside the loop. At the end, let's simply pass to the draw function the start index and the size of the index buffer portion. In this way, only the faces with the material we are currently considering will be drawn. Very well. At this point, let's update the update model method by changing, even in this case, the material parameter with a vector of materials. Here we have simply to set the various data to all the materials. Good, now we have finished. The last thing to do is to create our 3D scene concretely. As very first thing, let's start to render only the sky mesh. Now, in the drawMesh function, we have to pass a vector of materials. To do that, let's add a vector of materials in the app window class. Then, let's initialize this vector by reserving 32 slots. This helps us to avoid useless reallocations at runtime. In the drawMesh function, let's clear our list of materials and let's push the sky material. Let's pass our list to the drawMesh function. At this point, we can avoid to load all these meshes and textures, so let's comment or delete all this code. Let's change our skybox with the sky.jpg texture. Let's see if it works. And it works. As next thing, let's add a send terrain. So let's add, as usual, the mesh, the material, and the texture resources. Now we can draw this terrain in the same way we have done with the sky. But in this case, we will use even the update model method. Let's see if it works. And it works. But usually the sand is not so reflective. Let's reset the specular level in the pixel shader. Good. As the next thing, let's enlarge a bit our point light. In the update light, let's make our light static for now. Very well, now we have a sand environment. At this point, let's start to load the house with all its relative objects. As first thing, let's add the house mesh, all the materials. For this mesh, we have the barrel material, the brick material, the windows material, and in the end we have the wood material. As last thing, let's add all the corresponding textures. Let's load all the various resources and good. Now we can start to draw our house and all its objects. Pay attention now to the order in which the materials are added to the list. This aspect is really important because if the materials are placed in a different order, our mesh would be drawn incorrectly. For example, we could have the barrel material over the surface of the house, and so on. To know the exact order, it's enough to inspect the MTL file, where the materials are placed one after the other in a specific order. That is exactly the order we want to know. Good. Let's see if it works. And it works. But there is a little texturing problem. To solve this issue, we can easily go to the pixel shader, and here we have to invert only the y-axis of the texture coordinates, and not both the x and y axis. This because the mesh has been exported with the pivot of the texture coordinates on the bottom left, and not on the top left. Good, let's see if it works. And it works. As the very last thing, let's draw a 3x3 grid of houses. That's all for now, folks. Today we have seen how to make concretely a 3D scene. I hope you enjoyed this video. See you soon. Thanks for watching.